Grip and Rip Technology, a product development and engineering company specializing in swing dynamics, has adapted its technology program to the field of ergonomics. Embodied in an actual wristwatch, our newest device uses an array of highly sensitive electronic sensors to monitor and unobtrusively gather ergonomic data systematically and seamlessly while workers are performing their jobs in real time. Each hand and wrist motion and the associated force deployed with it is recorded and stored in the monitor's memory. The data can be aggregated and downloaded at the end of a workday, and each repetitive motion is identified with the time of day it occurred. Our versatile technology platform can be programmed to differentiate cumulative trauma-causing motions from random, irrelevant hand and wrist movements. Here we will illustrate how the device functions in collecting data pertinent to the risk of injury related to prolonged or improper computer usage. We power up the monitor by inserting the battery. A quick scan of numbers appear on the display, and then the time of day appears. Here, 8 o'clock is displayed. Note the flashing dot or period between the hour and minutes. This indicates the clock is running. Each time the hand raises relative to the wrist, the device recognizes the motion as an observation and it counted. The number displayed on the watch face related to the strain on the wrist. Generally, the higher the number, the greater the strain. There may be thousands of these motions recorded during an average workday. Once captured, the frequency and the force data can be downloaded and statistically analyzed. To display the saved data, simply press the Start button and 3 dashes appear. Next, pressing the Select button, time and each select press thereafter will show the saved motion of the hand relative to the wrist and the strain or force associated with it. Next, we will note that as the orientation of the hand to the wrist changes or deviates from the perpendicular movement, which is associated with cumulative trauma disorders, no observation is recorded. Thus, the software controls for random, uncorrelated hand motions that are not part of the repetitive type being monitored. The monitor also has a control for discriminating amount of pressure or force being analyzed. If one is interested in repetitive motions where considerable force is exerted, such as those involved in firmly gripping or lifting an object, a parameter setting of 7, 8, or 9 would be selected. Thus, motion without an associated significant force will be ignored or treated as random or noise. In other cases, it may be that slight motion with minimal force involved is the subject of interest. Here, the force parameter setting will be 1, 2, or 3. Having shown how the device collects data on computer usage, we will next illustrate an application where more significant force is monitored while lifting and gripping. The monitor starts recording data with the time displayed at 8:05. As the 10-pound weight is curled, the pressure readings are 81, 83, 70, and 71. As the 12-pound dumbbell is curled and gripped more tightly, the pressure readings are 108, 123, 111, 90, and 107. The data can be aggregated for each job description, and this may be an important source of information for setting baseline and threshold levels for where employees are at risk of injury. Risk profiles from the data gathered by our system can also be generated for individual workers, and when combined with demographic data, a company's safety practices and injury prevention programs may be greatly enhanced. We are launching a series of pilot programs collecting data on a variety of occupations where employees are at risk of repetitive stress injuries and cumulative trauma disorders. If your company would like to participate in these studies, let us show you how we can help lower your workers' comp expenses and create safer working conditions for your employees. Contact us at tedc@shotwatch.com to learn about participating in our program.